The heights of American men aged 18 to 24 are approximately normally with a mean of 67 and a standard deviation of 1.5. And we are looking for the 32 have outside the range. So if 32% have outside this range, 68% have inside this range, which is one of my key numbers in the empirical rule, which means we're talking about one standard deviation. So 67 plus one standard deviation would be 68.5, and 67 minus 1.5 is 65.5, and those are the numbers. Okay, same problem, or problem number 2, same situation. 67, standard deviation of 1.5, and we are looking for over 68 inches tall. So there's 68. So the first thing we do is we find a z-score. So 68 minus 67 divided by 1.5 is basically 0.67. If you are looking at the table, you look up a z-score of 0.67, and you get the answer of 0.7486. But that's not the answer because we're subtracting it from 1, which is 0.2514. Calculator, normal CDF, and my low number is 67. My high number is a really big number with a mean of 0 and a standard deviation of 1. And you'll get 2.2514 as well. And on to number 3. For number 3, we're looking for the standard, the percentage underneath. So look up a z-score of 1.1 in the table, and you'll get the answer of 0.8643. Look up a z-score of negative 0.5, and you will see 0.3085. And for those of you using the table, we just subtract those two numbers, and we get 0.5558. For those of you doing normal CDF, you just do negative 0.5 to 1.1, 0 and 1, and you should get the same answer of 0.5558. In problem number 4, if we're looking for a normal probability that is skewed to the right, that means that these numbers over here are spaced out, and these numbers over here are together, so the curve should look like this when it's skewed to the right. So that one is skewed right. If I'm looking for one that is approximately normal, we get one that is a straight line, essentially going from left to right. Properties of the normal curve. Area is equal to 1, symmetric, hills over the mean, and 68, 95, 99.7 rule applies to anything with a normal density. For problem 6, we have a mean of 25 and a standard deviation of 11.9, and the green line here is 27, and we are doing above 27. So first we find the z-score, which is the number minus the mean divided by the standard deviation. Which is 0.168, so we'll round up to 0.17. If you look up 0.17 on the table, you would get 0.5675, but because we're doing bigger, we're going to subtract that from 1. So that's 0.4325. For those of you using normal CDF, we got from 0.15 to 9999 with a mean of 0 and a standard deviation of 1, and we come up with the same answer. Seven, which of the following is not likely to have a normal distribution? We talked about salaries in class, an easy test, or few fail, or a hard test with few A's. Because chances are that would be something. What we're looking for in the normal distribution is most of the data in the middle, like IQ tests and heights. Those would be things that are approximately normal. For problem number 8, we're told that the mean is 68, and we got 76 to 60 has 95%, which is 2 standard deviations. So 2 standard deviations from 68 to 76 is 8. Just to make sure that we're symmetric, from 68 to 60 is also 8. So when I divide by 2, that means we have a standard deviation of 4. For problem number 9, they talk about Dow Jones increasing, so I'm going to do a mean of 3% and a standard deviation of 4. We probably use different numbers in class. So we want something that decreased more than 2%. So here's negative 2, and down here is decreased more than 2%. Remember, these numbers weren't on the test. I should have given it to you. The mean is equal to 3. So, first thing I'm going to do is negative 2 minus 3 divided by 4, which is negative 1.25. So look up negative 1.25 on your sheet, or use normal CDF in your calendar and your calculator, and we get 0.1056. Now that is the percentage, but we're looking for number of days, so I have to take the extra step and multiply this by the fact that there are 61 days in which these are open. So 6.4 days. By the way, for normal CDF people, you do negative 9999 to negative 1.25 with a mean of 0 and a standard deviation of 1. And for those of you in the table, just look it up in the table because we're doing the left side. For the 23rd percentile, look for the thing that is closest to 0.23 on the table, which is negative 0.74. If you do inverse norm of 0.23 with a mean of 0 and a standard deviation of 1, you get that 0.74 as well. X minus, what numbers did I use? 3 divided by 4. Multiply both sides by 4. And that's negative 2.96 equals x minus 3. So when I add 3, we get 0.04 equals x. Problem number 10. The mean is 0.69. The standard deviation is 0.16. So we're looking for the 70th percentile, which means 70% of my stuff is down here. And since they give me this percentile, we're going to use inverse norm 0.7 with a 0 and a 1. Or you look on the table for what is closest to 0.7, and you should get a z-score equaling 0.52. About equals x minus 0.69 divided by 0.16. Multiply both sides by 0.16, and we get 0.0832 equals x minus 0.69. Add the 0.69. And we get 0.7732. That's how many ounces. Part B says it costs extra, and if we go over 0.9, so what percentage is up here? Find the z-score. 0.9 minus 0.69 divided by 0.16 turned out to be 1.31. If you look it up in the table, you will see 0.9049, but that's for the stuff that's down here. I want the stuff that's above, so 1 minus 0.9049 is 0.0951. For those of you using the calculator, normal CDF from 1.39 up should give you the same answer. Last problem. Okay, David is a third grader and scored 80, and Nancy was a sixth grader and scored 90. So we're going to find the percentile for David first. He had a mean of 72 and a standard deviation of 10, which means 0.8. So when you look up your z-score of 0.8, or you do normal CDF, negative 999 to 0.8, or the table, you get 0.7881. For Nancy, 90 minus 80 divided by 11 this time is 0.91. Look it up on the table or do normal CDF from negative 999 to 0.91. Mean of 0, standard deviation of 1 as always. And we find out that the answer is 0.8186, which means Nancy is better compared to 6th graders than David is compared to 3rd graders.